Hello students, so you are most welcome in today's SAT Act number one class. So student, this video is very important for all those students who are looking for SAT preparation, and in this video we will study math. Okay, so I like to tell you students, if you are new in this channel in my videos, so please be with us because we are going to start our SAT preparation and we'll study each and everything step by step. Okay, so first of all I try to build your concept in the math or any topic which I'll teach here. First of all, I try to build your concept, and after that I'll take the your level question which is required for SAT entrance exam preparation. Okay, so in this video students, as I said that in today's video we are going to study math, and in math we are going to study the most important topic, most important chapter, which is called algebraic expression. Okay, and we'll try to understand each and every single thing of this chapter, that's been each and every single concept of the chapter. Okay, so first of all we try to understand student in this video variable. So what is called variable? So here we have a simple definition of the variable. So variable is means basically a variable is a letter or symbol that represent a value. Okay, an algebraic expression is one or more terms that contain a variables. For instance, we have some examples here. 3a y plus 1 x square plus 4x plus 4. These all are the examples of the algebraic expression and has a variable. So in the first like example in 3a we have the variable a, which is what, which is a kind of alphabetical symbol. Okay, and in second example we have y plus 1, again we have y, which is an alphabetical symbol. So we consider this symbol as a variable. So I like to tell you variable means actually what? Variable means actually it's an unknown number which is not any fixed, which don't have any fixed value. That's mean for the different expression we can have different like the values of the same algebraic or alphabetical value. So for example, if I talk about three different expression, or you can say equation, suppose we have the first expression x plus 1. Okay, and the second expression, suppose we have x square minus 25. Okay, and its third expression we have x cube, suppose x cube minus 27. Okay, so these are the three expression having the same variable x. So you can see this is the binomial terms having x, which is a variable. And the second example we have it's also a binomial term having x, the variable. And in third example we have x cube minus 27 having x, which is a variable. Okay, but this is a linear. Why? Because the degree or the power of this x, which is highest power of the expression, which is 1, so that is why we call linear. In the for second we call quadratic, and third we call cubic. Okay, which we'll study deeply later on. But here what we are trying to understand, actually we are trying to understand why this expression, why this like alphabetical value known as variable or unknown number, why it's varying. So these are the three examples of the expression. Suppose if I put here is equal to sign and I put after is equal to 0 number, so this is now known as the equation. Okay, so this is the only difference between the algebraic expression and the equation. When there is the equal sign, okay, when there is the equal sign in any expression, so that's known as that's expression known as equation. So the first one now become an equation. And again if I put here is equal to 0 in both the examples, so these three now become equation. So by solving this equation, what you will get? You will get the value of x for the first case, that is equal to minus 1. Okay, and what about this second example? So for the second example, the value of x, when you take this x square to the left hand side, okay, and this minus 25 to the right hand side, hope that you might be studied these all basic fundamental, these all basic concept in your previous, in your basic like classes. Okay, so here when you take this minus 25 to the right hand side, so it's become 25. Okay, what about the value of x here? The value of x is here, when you find the value of x, so you have to square root to the right hand side. Okay, so this will become 25, and you are going to put here plus minus sign. Okay, so now you have the value of x, which is plus minus 5. That's mean the value of x can be plus 5, or can also be minus 5. Okay, so this is the another value. We have just got the value of x for the same x. See, you can see here for the same x we have here -1, and for the same x we have here +5 and -5. And similarly, when we solve the last equation, which is x cube minus 27 is equal to 0, so the value of x cube will be is equal to 27. Okay, so after solving this cubic root, you will have x cube. This will implies to you x cube, sorry, the value of x is equal to, it implies x is equal to cubic of the 27. Okay, when you make the factorization of the under roots, that's mean 27, so you will have 3 into 3 into 3 times. Okay, that's mean you can now take outside the value 3, the number 3. So here you have the value of x is equal to 3. So what you can see here, for the same unknown number x, you have different values. In the first case you have the value of x minus 1, in the second case you have the value of x which is +5 or -5, and in the third case you have the value of x which is 3. So by this example you can understand it's a variable. The value of x is actually a variable which is not fixed, so that is why we call the value of x or x, which is alphabetical symbol here, it's a variable. Okay, which is an unknown number which is not fixed. Okay, hope that you have some idea about the variables. Now what about the next important part, which is called part of a term. What we call actually term. Okay, term is nothing but here, first of all we try to find what is the terms basically. So term means basically, suppose if I'm writing any expression, if I'm writing expression 2x square plus 3x. Okay, so this is a kind of algebraic expression. Here we have two terms. Okay, basically terms are separated by the mathematical operation plus and minus. Okay, so this plus separated these two terms. Okay, so now we can say we have two terms. Okay, suppose if there is -3, so we will say that we have three terms. How we got this? We got this by the help of the basic mathematical operation, which is here plus and minus. Okay, but what about the multiplication and divide? So if I'm writing here 2x squared and multiply by again x, so this is considered as single term. That's mean it's a monomial, because as I said that plus and minus only can separate the terms. So here for this expression you can see we have three terms. And what about the parts of the terms? So for the first term, okay, what are the parts of this term? So for the first term we have some numerical coefficient. Okay, this numerical value 2 is considered as numerical coefficient. Okay, and even the first term contains some factors. Okay, even we can also write this term 2x square like this, 2 into multiply x or multiply x. So if I take this x, so we have 2x as a coefficient. Okay, if like the question is like this, what is the coefficient of x square for the same term? So you will say the coefficient of x square is here 2, and if I'll ask what is the coefficient of x, so you will say for the same question you will say the coefficient of x is 2x. Okay, it's simple meaning. Okay, it's simple meaning if anyone asks for any term, the coefficient or the numerical, basically the numerical coefficient which is fixed. Okay, if anyone asks what is the numerical coefficient of the first term, so you're going to tell the numerical value only. Okay, but if anyone asks like taking any single factor of the term and ask what are the or what is the coefficient of the term, so excluding that term, suppose I'm asking what is the coefficient of x, so here you are excluding this x, okay, this x, and after that you are going to write all the remaining terms, factors, that is known as the coefficient. Okay, So hope that you have some idea about the parts of the term. Here the parts of the term is basically the coefficient, okay, which is very important, or you can also call some factors. Now we have third point, which is like and unlike terms. So here what is called the like and unlike terms. So we have a simple definition and simple understanding from this statement. The term x, 3x and 8x are like terms. Why? Because all these three examples, in all these three examples we have the same variable, okay, we have the same variable. So that is why we will call like terms, because these terms all have the same base or same variable. You can see here, okay, the terms 3x and 3x square are unlike because the variables in each term have different exponents, okay. So that simple mean when the variables are same for the different terms, so we call that like terms. And when the variables are same, okay, when the variables are same but the degrees are different, so that is called unlike terms. So for example, if we try to understand with the help of example, suppose we have the first example, we have suppose 2x, okay, in first example we have 2x, then comma, if we have minus 13x, okay. So both are here like terms, okay. We are not actually bothering about the numerical coefficient, okay. Here we have minus 13 and here we have plus 2, but we are not bothering about the numerical value, we are only bothering about the variable, okay. Here we in both the cases we have the same variable, which is an x, and we have the same exponent, that means same power, okay, that means same degree. This power is known as degree. Here in the first example, in the first case we have the power is 1. If there is no number, you know that there is number 1 always there. And in the second like example, in the second term, again we have 1, or we can say we have same degree in both the variables. So that is why we call like terms. So this is called like. So what we call like terms, okay, we call it like terms, right students? Okay, second example, suppose we have 3x square, okay, then 3x square y. Is it like term? Of course not. Why? Because see, we have same variable here, we have same variable in both the examples, but after like first example, you can see both the variables are same, exactly same, okay, having x in both the terms. But here we have another term which is y, okay. So that's mean x square is there, that is right, but we have another term as well, okay. But the condition is what? The condition is that every single term has to be equal. Every single term has to be equal number of variables, and degree also has to be equal. That's mean we cannot say these both are like terms, so we'll call unlike terms, okay. So it's a unlike terms, right students? So hope that you have now understand what is called like and what is called unlike terms. So let's move to the next point. We have the next point. Now combining like terms, okay. How we can combine the like terms? It's a simple mathematical operation which you have already studied in the basic classes. Suppose if I'll say you have to add 2 plus 3, so both are the numerical value, you can simply add and you will say 2 plus 3, that is equal to 5. But what about 2x plus 3y, okay? What about 2x plus 3x, sorry. So here as you can see we have 2 times x and 3 times x, so we can simply add both the terms. Why? Because having like terms, okay, having same variable and degree is also same, so we will simply, it's a very simple. If I'll say suppose Sonam is a girl. If I'll say suppose Sonam has 5 pencil, P means pencil here, right? Sonam have 5 pencil, and Mona has 6 pencil. Okay, consider this P as a pencil. Okay, so if I'll ask how many pencils are there together, both Sonam and Mona, so you will say it's simply by adding 5 and 6, so you will say here 11 pencil. So if we talk about how we are going to combine the variables, so here you have to simply add both the terms. Okay, if the variables are same, that's mean both are like terms, so simply you are going to add and it's become 5x. Okay students, so hope that you have now the basic idea about the combining the terms. When there are like terms, only in that case we are going to combine the variables. That means in combining, if I talk about the combining the variable, that's mean that simple meaning I'm talking about the addition of the variables or subtraction of the variable. If you will ask me what about the multiplication and division, so that have the different concept, and for that for like another concept which is called multiplication and division, we don't have any issue of checking the like terms or unlike terms. Okay, we can only simplify that. Okay, suppose for example, if I'll say what is the product of 2x and 3y. Okay, so you will say the product of 2x plus 3 into 3y, I can write here into. Okay, so the product of 3x and 3y, it's simple. Okay, so numerically we have here 2 and 3. You are going to multiply this 2 3, that's become 6, and again you have an x and y, so you are simply multiplying this x to y, and this is your right answer. Okay, so as I said, if we are like applying the other other mathematical operation except plus and minus. Okay, so there is no problem with that. Okay, we are not like bothering about the like terms has to be there or unlike terms should not be there. So in both the cases, so that's when we can apply. Okay, so now we have the next important point, which is called combining unlike terms. So how we can combine unlike terms? Okay, so let's have some example for combining the unlike terms. Suppose if I have first example, suppose 5x, and I have to combine this 5x with 25y. Okay, so what can I do? See, for this example, if we have to combine 5x with 25y, so I can't do anything. Okay, this is the answer actually. This is the answer actually. But one more thing, what I can add here, I can take the common factor outside. Okay, which is outside the bracket. I can put the bracket here. So I can see here, here is a 5x and here is 25y. That's mean 5 is a common factor in both the terms. So I can take this 5 outside, and simply here I can write here x plus 5y. Okay, so I can write this expression like this as well. But there is no change for both the expression. There is no change, both are similar. That's mean if the terms are unlike, in that case we cannot do anything. We can simply operate some mathematical property, and by that we can reduce that like expression. Okay students, so now let's see more points. Okay, now we have evaluate expression using subtraction. Okay, how we can evaluate expression using subtraction? So here we have some statement. Let's first we have to go through this whole statement. So to evaluate an expression given the value of the variable or variables in expressions, substitute the value for the variables in the expression. That's mean, what is the value of 7x plus 1 when x is equal to 5? It's a very simple, students. I like to tell you that if you have this kind of question, okay, and in which you have asked put a certain value, suppose in a certain expression, suppose if I am having expression x square minus 3x plus 4, okay, if I am saying that what is the value of this expression for x is equal to 2, so you are going to do simply going to put the value of x in the whole expression, okay, which is equal to 2, okay, and apply the basic mathematical property. Okay, so I am going to write here at the place of x, everywhere at the place of x going to write here 2. Okay, so because here the power is 2, so again I'll write here 2 raised to power 2, then minus 3 into 2, then plus 4. Okay, and now simply I'll solve it. So 2 square, that's become 4, 3 2 jars minus 6 and 4. Okay, so you can see here now it's simple, like addition, subtraction, simple integer sum. So 4 plus 4, that's become 8, 8 minus 6, that's become 8 minus 6, that's become 2, and that's your answer. Okay, it's very simple. So you have not to worry about this type of question. Okay, so let's now we have some practical problem. Okay, here is one more point: evaluate one variable in terms of another. So we'll try to understand the same in the practice, in the practical problem which we have now. Okay, so we'll start from the first problem, students. Okay, so we have the first problem. In the first problem we have 9a plus 12a square minus 5a. So you have to simply solve this problem. So what you can see here, you can see 9a and 12a square, both are unlike terms. That's mean we can't do anything for both the terms. But what about this minus 5? So if we talk about minus 5 and 3a, so definitely both are like terms. That means we can apply the basic mathematical operation here, and after that we can simply put. Okay, we can simply solve that. So let's solve this simple question. This question is a very simple question. If your maths is a little good, even in that case also you can solve this question. This is a very simple question. So here we have 9a, then 12a square, okay, then 12a square, then minus 5a. So as I said that 9a minus 5a both are like terms, so we can simply operate the mathematical operation. Okay, so 9a minus 5a, so here we have to simply subtract 5 from this 9, so you will have 4. That's mean because we have a in both the terms, so it's become 4a. Okay, so 4a plus 12a square, this is our answer. Okay, so or we can also write this in this way, 12a square plus 4a. Okay, there is no problem, no issue if I'm writing any term is in first place or second place. Okay, students, but have to consider the sign, because both the signs are here positive, so no problem. Okay, so we have the right answer, which is option number D. And what about the second question? For the second question, students, we have to apply some basic mathematical operation. This question is also very easy. Okay, let's solve this question. So there is 3a into 4a upon 6 into a square. So 3a in the numerator in 4a. Okay, I'm not putting the bracket, I'm simply multiplying it, and there is 6, then in bracket I'm writing at the place of bracket multiply sign 6a square. Okay, so what you are going to do, you are going to simply like cancel it. Count the table 3, so you have 3 2 times, that's become 6. So again when you read the table 2 of 2 times, so 2 2 ja 4. Okay, so you have 2 here, so now you can cancel this 6 by the numerator 2, so 2 3 ja. So you have a into a and upon 3a square. Okay, so here is in the numerator a, and in the denominator we have a square, so we can simply, because a square is nothing but the product of a 2 times. Okay, students, so you can write it in this way, a into a, and both will cancel out. Your final answer will be 1 upon 3, which is your answer. And there was no problem if you're solving this directly. Okay, because a, the power of a is 1, again here the power of 1 is a is 1, so you can write this a square upon 3a square. Okay, and finally you have the answer 1 upon 3. Or by simple consideration you can see that both are same, so you can simply cancel out and write 1 upon 3, which is your answer. Okay students, so hope that you have understand, and we have the first option which is the correct one. You can see how easy this question are. Actually I'm taking a little more time to explain you, otherwise this question are just only a second question. In a second you can do this question, or I can do this question. Okay, what about for this question? For this question, students, let me explain this question. We have 5a plus 7b. We have 5a plus 7b in the numerator. Okay, let me write this first. Sorry. We have 5a plus 7b, then bracket. Okay, then b is there outside the bracket. In the denominator there is b plus 2a. b plus 2a. So can we do anything? Of course not. We can't do anything for this expression, because there is not any single common factor or a numerical value which is common. Okay, so I can't do anything. That's mean this is what the answer. I can't do anything. So but we are getting here no MCQ, no options are similar. That's mean in this question there will be, sorry, here is b plus 2b actually, students. So I made mistake. B plus 2b. Okay, so right here 5a plus 7b. Okay students, I made actually mistake in writing the question, so that's why I was saying like that. So b plus 2b both are like terms, so simply we can add here, so it's become 3b, and b, this b will be considered from this b numerator, and finally we have answer. Now we have the answer in the option, so this is our right answer. Okay, so we have option number D, which is the correct one. So student, next question. Again I like to tell you, student, questions are really very easy question, so you have not to worry about this for this types of simple question. Okay, but no problem, be with us, and after that, after completing this practice problem, I'll take difficult question as well. So this video is basically to build your basic concept. Okay, if your basic concept is not up to that mark, so in that case this video is really very helpful to you. Okay, so what about the question number 4? So here we have 2x square plus 4y square plus 6x square y square. Okay, so I'm going to write this question here. So we have 2x square plus 4y square in bracket. So in place of bracket I am writing here multiply 4y square plus there is 6x square y square. See, what can I do? Okay, what can I do this question? For this question we can simply first of all solve this first term. I'm going to multiply this 2 with this 4 number, so that's become 8x square y square. Now you can see both the terms are like terms, because in both the terms we have same degree variables. In the first term we have x and the power is 2, and y the power is 2, and in the second variable also we have the same power. So we will simply add this 8x square y square plus 6x square y square, and what is the sum of 8 plus 6? 8 plus 6, that's become 14. So finally we have our answer 14x square y square. Okay, and this is the right answer. So we have option B, which is the right one. Okay students, so next in problem number 5, we're going to solve the problem number 5 now, and this is the last problem for today's class, because now our class been for about 30 minutes. Okay, after completing this class I'll give you some homework, so you have to do your homework and directly can message me, or you can install WhatsApp application, or from there also you can message me, you can directly chat with us. Okay, chat with me, I mean to say. So here when the x is equal to 3 and we have some expression which is expression which is 2x square minus 5x plus 3, so we have to find out the value of this expression, which is 2x square minus 5x plus 3. That's mean we have to simply put the value of x in the given expression. Okay, so what I am going to do here, I'm going to write 2x square minus 5x plus 3. So here 2x square, okay, minus 5x, then there is plus 3, and I'm going to write the value of x, which is 3 here. Okay, so I'll put at the place of x 3, so 3 square then minus 5 into 3, then plus 3. So the square of 3, see, square of 3, that's become 9, okay, and 5 3 ja, that's become minus 15 here, then plus 3. So 9 2 ja 18. So if you have both the sign combined, okay, plus, minus, multiply, divide, so you must have to follow the BODMAS rule, okay, BODMAS. If you don't know what is BODMAS, so I'll let you know in the next video, okay. So 9 to the 18 here, minus 15, then plus 3. See, you can see here 18, which is having plus sign, and 3, that's is in plus sign. Both the integers are positive, so simply we'll add 18 plus 3, that's become 21. So 21 minus 15, when you subtract this 15 from this 21, you will have your answer, which is 6, and which is your right answer. Okay students, so hope that we have now the answer is minus 6 here, sorry 6 here, option number C. So you can see we got all the answers correctly, and now you have some question which is in homework. So I'll give you question number 6 is in homework, question number 7 is in homework. Please take this screenshot, or you can directly write the question, and you have to solve this question for yourself, and after that you can directly tell me your answer in the comment box. Okay, so till question number 10 you have to solve. Okay, if you like to solve more questions, so you can take more questions, even in that case, no, there is no problem. Okay students, so hope that you have enjoyed this class. Okay, as I said students, in today's class we have studied very basic concept of the algebraic expression for SAT. Okay, if you're preparing for SAT, so this video is really been very helpful to you if your basic math is not very good. Okay, but please be with us if you like to prepare more and more maths, and later on in my later videos I'll take difficult question as well. Okay, so please be with us and like keep learning step by step. Thank you so much. Have a great day.